So we got through some of it. We got all that stuff done. We got our sign chart done, and we were about to check to see if our function intersects our asymptote. But let me remind you about the sign chart, because I had this question last period, and the question was, what was the shortcut you showed us? So when you do the sign chart, you have to do at least one section. It's easiest to do the first. I mean, it just makes the most sense. So you do this, and we figured out that it was positive. The only reason it would not alternate signs at each number that we put on there is if you have tangency or togetherness, right? And so we didn't have any tangency or togetherness on this one, so that's what allowed us just to go positive, negative, all the way down. Okay, we good with that? Okay, perfect. So if I want to see if these intersect, I have to use a multiplied together version, which I didn't actually get from the beginning. Like, it was partly factored before I ever even started, and I've got to multiply this back together. Or I've got to multiply it together, not back together. And even if you started with a multiplied together version, you may have to multiply some stuff back together if you cancel things out as you go, okay? All right, so in order to do that, hang on, I've got to pause for a second. Okay, so I'm going to start by distributing the x squared. So x squared times x is x cubed. X squared times a negative 1 is a negative x squared. And I'm distribute the negative x. Negative x times x is negative x squared. Negative x times negative 1 is a positive x. Negative 12 times x is a negative 12x. Negative 12 times 1 is a positive 12. All right, so that's my numerator. Denominator, x squared times x is x cubed. X squared times a negative 2, negative 2x squared. 2 times x, 2x. 2 times negative 2, negative 4. Okay? So then I need to clean this up a little bit. In the numerator, I only have an x cubed, or I only have one of them, rather. Then I have negative x squared and negative x squared. That is that correct? Yeah, that's correct. Negative 2x squared. Sorry, I had that moment of. And then x and negative 12x is negative 11x, and then plus 12. Then the denominator is good how it is, so x cubed minus 2x squared plus 2x minus 4. Okay, everybody good? Because again, you got to be able to not only factor things, but you got to be able to multiply them back together. It's all the big picture of basic algebra. All right, so down here, we've got y equals, so what was it, x cubed minus 2x squared minus 11x plus 12 over x cubed minus 2x squared plus 2x minus 4, and then the asymptote, y equals 1. So we take the 1, we substitute it in for y, so we get 1 equals x cubed minus 2x squared minus 11x plus 12 over x cubed minus 2x squared plus 2x minus 4. Then we multiply both sides by the denominator. You get x cubed minus 2x squared plus 2x minus 4 equals x cubed minus 2x squared minus 11x plus 12. So then I start to solve. You can subtract x cubed from both sides, those zero out. Add 2x squared to both sides, those zero out. So that leaves me with 2x minus 4 equals negative 11x plus 12. So I'm going to add 11x to both sides, and I get 13x. Add 4 to both sides, that equals 16. So x equals 16 over 13. And that tells me that it does intersect the asymptote when x is 16 over 13, which is just a little bit more than 1, right? So we can go to a little bit more than 1, and that's where we cross the asymptote. And then I have other things to put on here. I have 3 roots. I have one at -3, one at 1, one at 4, and then my y-intercept was at 0, -3. Everybody with me? Okay, so I use my sign chart from -infinity to -3. My function is positive. So not only do I know that it's positive and it has to stay under the asymptote because it only intersects at one place. So that section looks like that. Then from -3 to 1, it is negative. So here's -3, here's 1. So this is going to come down. It's going to have to hit my y-intercept and then come back up to 1 while it's negative. Okay. And then from 1 to 2, it's positive. So from that 0, it's going to have to cross through that asymptote at that point we found. Look like that. Then we know from 2 to 4, it's negative, so it's down here, like that. And then from 4 to infinity, it's positive, and it stays underneath the asymptote. So it looks like this. What questions you got? Good. All right, so your assignment, you picked that up yesterday, so you're going to have the rest of the period to work on that. The key is over there on top of the phone case like it was before, so that you can check yourself, work with each other on it, ask me questions. We good?